Okay, second hi to my panel, to my supervisor and my fellow friends. My name is Nur Anis, student of Zamri. I will presenting development of an intelligent IoT-based monitoring system for power quality application, which is my final year project. So for the abstract, increased nonlinear load elements used in power quality system has a negative influence on power quality. Also, continuous monitoring of power quality disturbance for long duration make it difficult to realize the real-time monitoring due to CGI loading, computer-generated imagery. It is important to take an immediate action when the power quality events are occur to prevent the important equipment such as computer and communication equipment from serious damage. Therefore, this project aims to monitor power quality signal occur in a electrical load in a real time as well as analyze the measured data online. This project was achieved by applying the IoT system in order to send the measured data to the cloud via integrated Wi-Fi in ESP32 module. This project also used 20 multiply 4 LCD display to display the measured data, and the same data which have been displayed will be visualized in ThinkSpeak Cloud. This project employs ThinkSpeak, a web service which is comprehensive in storing sensor data and presenting the detected data output in graphical form at the web level in real time. Any power quality monitoring program truth value is in its capacity to analyze and interpret large amount of raw data and create actionable information to prevent PQ problems or improve overall power quality performance. So this project will analyze the measured data visualized in ThinkSpeak Cloud to seek for power quality signal as simplified. This project is created to improve the assistance of monitoring system for power quality application by monitoring PQ signal or power quality signal before power quality events happen. So for the introduction, so for the problem statement, increasing the use of non-linear load elements in power quality system could increasing harmonic distortion and harmonic humming all load linked to a power system point of common coupling, which is PCC. Continuous monitoring of power quality disturbance for long duration make it difficult to realize the real-time monitoring due to the CGI loading. And lastly, a country economy also will suffer greatly with even low cost tech industry suffering significant financial losses because because of poor power quality leads to expensive costs. So this project have three objectives, which is to design and develop an intelligent IoT-based power quality monitoring system. The system will be constructed using microcontroller-based platform and IoT cloud platform. Second is to monitor power quality signal occur in electrical load from a single phase connection as well as analyze the measured data online. And lastly, to evaluate and verify the performance of the design power quality monitoring system via experimental setup. So this project have two scopes, which is to design and develop an intelligent IoT-based power quality monitoring system using microcontroller-based platform and IoT cloud platform. This project use microcontroller, which is ESP32, and IoT cloud is ThinkSpeak Cloud. So second, to monitor power quality signal occur in electrical load from a single phase connection as well as analyze the data measured online. So for the literature review, harmonic voltage and current generated by non-linear load would raise the energy cost while simultaneously increasing the demand charge. A monitoring system can be useful diagnostic tool to detect problem circumstances before it produces interruption or disturbance. There is no difference between measuring power quality and measuring voltage and current from the standpoint of pure measurement. The Internet of Things (IoT) appear to be a promising key for online monitoring and related operations. ThinkSpeak is comprehensive in storing sensor data from various IoT applications and presenting the detected data output in graphical form at the web level, and it connects via an internet connection. So this project methodology, so the flowchart will go from start to the end. So we load sensor library and define pin in Arduino X software. So this project seek for data, which is current, voltage, power, and power factor. So if the coding is verified with an error and could be uploaded, so the measured data will display at 20 multi-breadboard LCD at the same time at TeamSpeak Cloud. But to connect to the TeamSpeak Cloud, we need to enter the network credentials. So we enter our SSID, which is our name of the Wi-Fi, and password. So if it's not incorrect, so we need to check the connectivity and retry with valid SSID and password. So try to reconnect with the enter network. So ESP32 will connect with the enter network and establish internet connections. So our data will get to transmit to the cloud, in TeamSpeak Cloud, the internet. So we could visualize the sensor measure data globally in teamspeak.com using web browser. So this from the data that we transmit to the cloud, we could analyze. We need to analyze the data in order to seek for PQ signal. So this is the load used for this project. From the single phase power connection, go to the distribution box. Then MCCV will connect to the power socket outlet, and one from the to the switch, which connects to 3 LED that connect in parallel. So in order to seek for PQ signal from the measured data, so we need to enter using some formula, which is V normalized equals to V measured over V nominal. V measured, which we measured from the loads, and V nominal we refer to the rated current or rated voltage from the specification of the load. So if there no if the load did not give any current, so we could use this formula, which is rated current equals to power over rated voltage. So after we verify the coding without an error, we will upload the coding, so it will port to the microcontroller. So based on this, we can see the voltage and the current value after we calibrating, and the power factor and the power. So if the channel state channel update successful, means the measured data is successful update at the TeamSpeak Cloud. So in order to check what we calibrate in coding is accurate or not with the measured current and voltage from the load, so we use we test using multimeter. So we test the voltage at the dB box. And for the current, we use clamp meter, and we tap at the layer of each load. So for LED lamp, it use 1.3 ampere, and for the electric pan, it use 1.523 ampere. So this project have been run for 5 minutes to collect the voltage, current, power and power factor value for 5 minutes. So this is the times that been taken. So from 11:25 until 11:29. So based on voltage nominal, we take from the rated voltage at the specification of the load, and for the current also we take from the rated current at the load. But for electric pan, the rated current has been not stated, so we use formula P equal IV to get the current nominal. So these are the value for measured voltage, current, power and power factor. So using the formula V normalized equal to V measured over V nominal, so we get the value of 1.09 pu. So if there has a PQ signal in the load, should be below 0.95 or exceed 1.05. So as we could see, as shown at the taken data, there has a PQ signal detected in the electric pan. So this is the graph. So we could see that it exceeds the 1.05, means for voltage, means there has a PQ signal in voltage, and there has also a PQ signal in the current. So in LED load, there's no PQ signal in the voltage, but there has a PQ signal in the current because it exceeds below 0.95. So to reconfirm about the data and the PQ signal has occurred or not in this measure data, we will run testing using PQ analyzer to see if there has any PQ events happen in this two load. So using normalized and normalized value, we could see there has a PQ signal in the load. So we need to confirm by testing using PQ analyzer. So after we switch on the LED lamp, okay, the LED lamp is on. So because we already clamp the live wire, so we could see the current flow is have THD in it. This is for the LED lamp, and if we tap, put the voltage prompt, so there's no THD. But as in this video, you can see that the voltage and ampere is so high because there has an error in the PQ analyzer. We turn off the LED lamp and switch on the electric fan. Okay, so electric fan is on mode. So we tap the current, there's THD. Also we take the voltage, and also there's no THD in voltage. It means this electric fan has PQ signal. Also by the measured data of our factor, we could see that the PQ analyzer shows that it's near to our what we measure in power factor. And if we on both load, we could see some THD in the waveform. So because we switch on load 1 and load 2 at the same time, so we can see the LCD display updating the measured data. So if the LCD display updating in the data, the ThinkSpeak channel also will be updated. So after going through the methodology and the hardware presentation, this result is gained from the project, which is for load 1, field 1, field 2, field 3, and field 4. And for load 2, field 5, 6, 7, and 8. This is for electric pan, and this is for the LED lamps. So based on the formula we use, we could see there has a power PU in voltage in electric pan, and current in the electric pan, voltage and current, but only current in LED lamp. So this is a PQ analyzer. So in the PQ analyzer, we could see that there's no PQ signal in voltage, but there's a PQ signal in current. Same goes to the LED lamps. Only the current have the PQ signal. So if we combine, we can see that there has a PQ signal in the current. So in conclusion, IoT system applied in this project to reduce the concerns of difficulty to realize the real-time monitoring system due to the CGI loading, and the system can be run for a long duration. In ThinkSpeak Cloud, the monitoring system can be done for unlimited time as long as the Wi-Fi connection is connected. This project can also reduce power quality events from happening by monitoring the measured data to seek for power quality signal occur in the system. The problem for this purpose project is the minimum time delay for the measured data can be updated in ThinkSpeak Cloud is 50 seconds. And for free user, for the user that have license is 1 second minimum. And also the ThinkSpeak Cloud only has 8 field, which means only 8 data can be transmitted. So lastly, the PQ signal also have been difficult to find because the delay time is considered long. The most accurate time that this project should use is the millisecond. Okay, that's all. Thank you.